In this problem, you're in a car headed one way and there's another car going the opposite direction. So both the source and the observer are moving. And we know the speed of sound, we know the velocity of everything, and the car approaching you sounds their horn at 1643 hertz. What frequency do you hear? Well, this is simply the full-blown Doppler equation, where the frequency observed is the frequency of the source onto the velocity of sound plus or minus, pardon me, the velocity of the observer divided by the velocity of sound plus or minus the velocity of the source. All right, and so now we just have to sort out the pluses and minuses. Well, if you're headed towards the sound, that's a plus. So you're headed towards the sound, and so in the numerator, we have the velocity of the wave plus the velocity of the observer. And I can't type today. All right, and in the denominator, if the sound is headed, the source of the sound is heading towards you, it's the minus sign. And so now you have the equation for the frequency you hear given all the other information in the problem. So let's go here. Velocity of the observer is 18.2 meters per second. Velocity of the source is 10.7 meters per second. Velocity of sound is 347 meters per second. And the frequency of the source is 1643. And so the frequency we observe is going to be what? The frequency of the source times the velocity of sound plus the velocity of the observer divided by the velocity of sound minus the velocity of the observer. So 1784. And the great thing about a lot of things in physics is you can ask yourself, does this intuitively make sense? The frequency is higher. That's what you would expect. So intuitively, this is in alignment with what you should expect. All right, that's it for this problem.